All right, thanks very much. So I'm reporting on work done in the last year under the CCS, that's carbon capture and storage. And of course, the part we're concerned with at the GSC primarily is geological storage. And the title there, that's actually the title of the proposal that was funded to do this work. So the project members, it's a large group who contribute various elements to the project overall, but the principals at the GSC over the last year or two are myself and Jim Craven. We're both in the Central Canada division, and Vicky Cheerhart was involved in some field work last year. So you can see there are people from the GSC, other parts of NRCan, some industry, Canadian universities, and then some international participation in the project. I assume you can hear me okay. Was that a yes?
Jim, oh, yes, that was a yes. That was a no.
Yes. Okay, sorry. Just want to make sure I'm not talking to myself.
No, you're perfectly. That's
okay. So when we go to look at CO2 storage, people have been looking at this seriously for the past 20 years or so. You do some calculations to get an idea how much CO2 can you really store. And what it essentially comes down to is the volume of the rock where you're going to store the CO2, the porosity of that rock. There's the density of the CO2. But then there's this E factor. And this is an efficiency factor, which has, you can measure it in a laboratory on small pieces of rock, maybe, but we don't have many field measurements on a large scale of what the actual efficiency factor is in a storage project. And as we move to large scale storage in Canada, which seems to be happening these days, this is really important. We have to move from these theoretical capacity estimates that we have to capacities or resource estimates that have some basis other than assumptions. So that's what this part of the project has been about. So in this slide, you can see an example. This is from a laboratory study. On the left-hand side, we have a porous sandstone that's filled with brine. And then when CO2 is injected, you can see on the right-hand side how a CO2 bubble has invaded and replaced much of the brine. But you can also see there is a certain amount of connate or water that will not move out from the rock itself. And with a very complex pore structure at different scales with fractures, etc., this is what results in or contributes to an efficiency factor. So the research objectives in the last year were expressed here. We want to image CO2 saturation with an existing large CO2 plume. This happened at the Aquastore site in Saskatchewan, where we have been injecting CO2 over the last 8 years, I guess it is now. And really, this is the main intent is to get a handle on real measurements of efficiency factors in situ. This should result in more robust storage capacity estimates, and the information is being used to inform regulations and international standards that are being developed. So this is the Aquastore site that I mentioned, where we currently have about 500,000 tons of CO2 injected. It's sitting in a clastic reservoir down here just above the Precambrian basement at about 3,400 meters depth. To date, we have been able, using surface seismic methods, to watch over time how the CO2 plume has developed in the reservoir. So this is a plan view map of time-lapse seismic imaging, and the blue, purple to white indicates the area of the reservoir that has changed, from which we infer we have CO2 expanding. But what we really want to do now is to make some measurements within the reservoir itself and use other methods that are complementary to seismic methods. Seismic methods are very sensitive to the presence of CO2, but then the sensitivity is relatively flat as the saturation increases, whereas electromagnetic measurements, which measure the resistivity, they provide a more even sensitivity as saturation increases. So we've applied two different methods here: crosswell seismic measurements and electromagnetic measurements made from the surface. So these are the measurements that were made using crosswell seismic. So we'd lowered a source down one of the wells and recorded energy from that source in the adjacent observation well. And this will provide an image of the reservoir in high detail. Why would you want to do this? On the left-hand side is the kind of detail you get from crosswell imaging as compared to surface seismic, on the right-hand side. So you can see the difference in resolution, the kind of detail you get from crosswell measurements. Just a field view of instruments being deployed in the injection and observation wells at the site. You need two big cranes to do that. There were a variety of challenges when you go to do this kind of measurement. The original measurements were made prior to injection in the well, but now this is an operational well that's under pressure. There's CO2 in the well, and here we have conditions that make it difficult to acquire new seismic data. Here's a concrete example of that. This is a photograph taken downhole showing the buildup of salt within the borehole, which limits our ability to get to depth in the reservoir. These are the preliminary results from the crosswell imaging. On the right-hand side, that was from the original survey prior to the start of injection. On the left-hand side are the results from the more recent survey, and I've circled the zone of interest where we will be taking a closer look at CO2 saturation within the reservoir. That is where we know the plume is. I mentioned electromagnetic imaging. In this case, we're using an electric source at the surface and measuring the disturbance in the resulting fields that occur as we put CO2 into the reservoir, because CO2 is more resistant than saline brine. This field work was done last summer. We don't have a lot of results to present at this stage, just some field pictures and a location map showing where the data were acquired along a single profile at the Aquastore site. The fact that we have large offsets in this survey allows us to penetrate to depths where the CO2 actually resides. Just an example of data from that survey, which are currently being analyzed, as I mentioned. The longer periods and larger offsets used in the survey allow us to penetrate to reservoir depths. So if you're interested in the project and want any more information, you can contact either myself or Jim Craven, and there are a few live links here where you can go and look at some videos that have been taken during fieldwork at the site. And I'll finish there. Thanks.